Hello and welcome to R&D Mathematics. Today we are going to again find inverse of a function, and in this one we will be looking at some restricted domain, this idea. But first, let's take one example that we did in last two videos. This is the first example. It's easy to use, f of x, 2x plus 4, and the inverse of this, f inverse of x, 1 half x minus 2. Now, you know how to find this. I already found twice the inverse of this in last two videos. Now, I want to show you something here. Now, you know how to draw the graph of linear function. An easy way is xy values. Let's take f. I mean this guy, when x value is 0, you see y value is 4, and when y value is 0, so I make 0 equals 2x plus 4, so 2x equal negative 4, x equal negative 1 half, sorry, x equal negative 2, so negative 2 comma 0. So these are the x intercept and y intercept. So 0 comma 4, 1 2 3 4, this point, and negative 2 comma 0, 1 2, this point. So your graph of f looks like this, right? And now let's deal with f inverse. Again, let's do the same trick. There are so many different ways of drawing it, but let me quickly use this. So if I put x equals 0, that's negative 2, so I'm taking here. And if I take y equals 0, so 1 half x minus 2 equals 0, so that's going to be x over 2 equals 2, and x equals 4. So 4 comma 0 and 0 comma negative 2. So 0 comma negative 2, 1 2 right here. 4 comma 1 2 3 4 right here, and it looks like this. I tried my best to draw it as nice as possible. Now look at these two graphs. Can you see something special? Let me write down these numbers. This number is 0 comma 4, and this number is negative 2 comma 0. And look at the other numbers. This number is 4 comma 0, this number is 0 comma negative 2. Now see, this point is 4 units away from origin, and this point also 4 units. And look at these numbers, 4 0, and here 0 4. It was reverse, 0 negative 2 and negative 2 0. So that means these two lines actually symmetric about y equals x axis, because f times f inverse of x equals x. If you think carefully, see, if you apply this graphically, for example, let's say f inverse of x, let's say f inverse of f inverse of 4, that's going to be 0 according to this point. F inverse 4 going to be 0, 4 is 0. And if you check f of f inverse of 4, that's going to be 4, because see, x and x. And let's check, f inverse of 4 is 0, and f of 0 is, see, f of 0 right here, 4. So that will always happen. In particular, if you take some point, a general point a b, the corresponding relative point somewhere here, that's going to be ba. That will always happen because it's symmetric. Now we are going to use this to show some nice things, to see some nice things. But before that, no, let's do it together. So how about this example? Now if I ask you to find the inverse of this, first of all, is it 1 to 1? Yes. Let me draw the graph. Root x looks like this, and you have plus 2. Because of that, this will shift 2 units to the left. So it will look like this, right? Now, in order to, yeah, so this is x plus 2. Now, what is the domain of this? Domain of this function is, see, when you project it down, domain started from here to right hand side. So the domain of this function is actually here negative 2 comma 0. So negative 2 to infinity. Because again, reminding all earlier things that we did, you take this and make it greater than or equal to 0. That's how you find the domain. So you get this. Now let's find the inverse. And it's 1 to 1 clearly by horizontal line test. So x plus 2. Again, you can use the thinking backward, but I don't want you to do that in difficult ones. But you can try and see whether you can get. So you reverse, sorry, you switch x and y, and then you solve for y. You have to square both sides in order to get rid of radical sign. And y is going to be x squared minus 2. Now, this is a problem we have to talk a little bit. In general, y equal x squared minus 2 graph looks like this. Y equal x squared graph, the base function like this. Because of that, y equal x squared minus 2, it will go 2 units down. It will look like this. It's not 1 to 1. Now, do we have a problem? Because normally we talk about inverse of functions. With 1 to 1 function, it has, this function is 1 to 1. And the inverse of that has also to be 1 to 1. Now, this is a very tricky point that I have to address. Now, look at this graph. Look at this. Let's try to, you know what, let me erase this part. Let me erase that part and try to, okay, the axis. And let me draw the y equals x line like this. So y equal x line, and few minutes ago we learned graphs of inverse function and the original function. They are symmetric. Now, how do you draw symmetric line? If you think about this, see, if you carefully, if you forget about, if you forget about this part, I'll draw that again. This part will look like this, right? Now this is an easy technique to draw. Now it's symmetric. And now let me again put that part back. So that part is going to be like this. That's all. You do not see this point. The corresponding point is this point, this, and this point somewhere here, this and this point, they together coincide, and it keeps going like that. Now if you observe carefully these two graphs, see, the green color one is only one part of x squared minus 2. And if that means if I restrict my domain, now this function is 1 to 1. Can you guys understand that? If I restrict my domain, so if I call f inverse of x squared minus 2 with x greater than 0, now this function altogether is 1 to 1. Now this is the part I wanted to teach you. Now, let me erase this part over here so I have more room. Now look at this very carefully. The domain of the blue one, this function here, we already found it, negative 2 to infinity. So domain of our original function is negative 2 to infinity. It must be exactly same as range of inverse function. Now let's check. Range of inverse function, and if you project your green color one, to find range, you project it to y-axis. See, it started from negative 2 all the way up to infinity. Makes sense. And let's check the other part. So range of our original function. Range of our original function, the blue color one, project it to y-axis. See, everything starting from 0, so 0 to infinity. And let's check the domain of f inverse. So the domain of green color one, if you project it down to x-axis, you see we can only put, because what I did was I restricted my uh, function only to positive side when I was drawing it, so it's 0 to infinity. Now everything nicely makes sense. So sometimes in order to talk about inverse function, you may have to restrict it. So you have to restrict and get rid of the many to one part and make it one to one. This is a nice example to make you understand that. So for example, now we started with this function. What if I ask you, this question? What if I ask you to find inverse of this function? Find inverse. If I end my question like this, actually this question is wrong. But if I word it like this, find inverse of f of x equal x squared minus 2 x greater than or equal to 0. So in this case, see x squared minus 2, it looked like this, but I am restricting my domain, so only this part, not the other part. In that case, see that function is 1 to 1, and yes, this is a valid question. Okay guys, I think you understood that. So that's all about inverse functions. Thank you.